Today we're looking at the distance between a point and a line. So whenever we talk about the distance between these two things, we always talk about the perpendicular distance. And the reason for that is if we're considering this point here P, which we're calling x1, y1, and the line ax plus by plus c is equal to 0, well, we talk about the distance between them. That's different depending on what direction you travel in. So the distance from here to here, from here to here, from here to here, we can go to any point. There's an infinite number of distances that we can use, so everybody would get a different answer. So what we do is we use the perpendicular distance. So we take that one that makes a right angle with the line ax plus by plus c is equal to 0, and we only talk about that. Now the formula you'll see here, d is equal to the absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. Now the proof of this formula is quite convoluted, so I'm not doing it in this video. There's going to be a separate video afterwards to show you where it comes from. I want you to get your head around how to use the formula. It is a formula you need to memorize. It is not one that you are going to derive easily in an exam, so you need to learn it. The video that I'm going to upload is going to be by somebody called Mr. Wu. He is an Australian teacher and he uploads a lot of videos. So if you're ever watching one of mine and you don't get it and you need more explanation or a different type of explanation or example, he's somebody that you can look up. It could be very, very helpful. Alright, so you can see the question we have here. We need to find the perpendicular distance between the point 2, 3 and the line 5x plus 2y minus 1 is equal to 0. So 2, 3 is our x1, y1. And the line 5x plus 2y minus 1, a is 5, b is 2, and c is negative 1. So we're going to substitute them straight into our formula. So as per all the other videos I've told you, you need to start with that formula, because if you screw up the formula but you've identified your a, your b, your c, your x1, your y1, you can still get some points, okay? So then substituting into that, we get the absolute value of a is 5 times x1, so 2, and then it's plus b, so 2 times y1, which is 3, and then minus 1. So what you're doing is you're taking that point 2, 3, and you are substituting it into the equation 5x plus 2y minus 1. All right? And then we put that over the square root of a squared, so 5 squared, plus b squared, 2 squared. Okay, now at this point, it's straight calculator work. Unless they ask you to find the exact distance, you can type this straight in. So into your calculator, start off with your fraction, and then this button here is your absolute value button. So you'll see the absolute value signs come up, and then you type in exactly what you've got here. So 5 times 2 plus 2 times 3 minus 1. And when you go down, put in your square root, and we need 5 squared plus 2 squared. So be very careful of a few things. 1, that all your positives and negatives are correct. And 2, that the 5 squared plus 2 squared is all under the square root sign. Once you've double checked that you've got everything right, press equals and you get your answer. So this distance is equal to 2.785430073. Now if they had asked for an exact distance, then you wouldn't type it into your calculator. You would need to leave it with the cert on the bottom. Now this question here, show that the points 1, 0 and -3, -1 are on the opposite sides of the line. Now how do you think I could possibly show that things are on the opposite side of the line? Well, we talked about the fact that absolute value is only considering the distance, not the direction. So if I need to consider the direction, then I ignore the absolute value. So other than that, it's going to work exactly the same, but what we're trying to show is that one of these is a positive distance and one of these is a negative, because that would mean they're heading in different directions. If the question asks to prove that they're both on the same side, you would show that they both have the same sign. So, same formula, but now no absolute value. So just ax1 plus by1 plus c all over the square root of a squared plus b squared. Okay, now I'm going to use the point 10 first. A is equal to 4, B is equal to -3, C is equal to 6, so we're just substituting in. So 4 times 1 plus -3 times 0 plus 6 all over the square root of 4 squared plus -3 squared. Now be careful, that -3 squared is going to give you 9, not -9. If you type this in wrong, your calculator is going to tell you you have a math error. So when we work this out, 4 times 1, 4 plus 0 plus 6. So we get 10 all over 5. So the distance here is 2. And I'm going to call that distance 1. And then we're going to start working on distance 2. So now we're going to look at distance 2. Now your A, B and C haven't changed because we're measuring them both from the same line. Your x1 and your y1 have changed though. So we start off the same way. We've got 4 times, but now we're multiplying it by -3, plus -3 times 1 plus 6. Now that's all over the square root of 4 squared plus -3 squared. Okay. So again, you can go back to your calculator. And you're going to work the same way except without your absolute value sign. Now we get a negative distance. We get -9 over 5. So because one of these is a positive distance and one is a negative distance, they must be on the opposite sides. Now remember, if the question said show them on the same side, you would show that they were both positive or both negative. Alright, so for the last exercise in this topic, 7.8, I want you to do some of each of questions 1, 2 and 3. More if you need extra practice, but if you're good with this, feel free to move on. You must do questions 5, 6, 8, 12 to 15 and 18 to 20. You can do the ones in between if you need the extra practice. Good luck and I'll see you in class.